the normal distribution. Example 1. So we're looking at the heights of 4-year-old children, and the mean height is 100 centimeters. The variance for their height is 9, and that would be the units squared, and the standard deviation is the positive square root of 9, so 3 centimeters. Standard deviation is a measure of spread in data. It's always a positive value, like all of the other measures of spread in data. Now 68% of these children will have a height between two values, a lower limit and an upper limit. And from what you've seen already, that will be the mean plus or minus 1 standard deviation. Mean plus or minus 1 standard deviation, so 100 plus or minus 3, lower limit, upper limit. So 68% of all children in this population will have a height between 97 centimeters and 103 centimeters. We can do something similar with the 95% value here. So 95% of children will have a height between 94 and 106 centimeters. So that's just the mean plus or minus 2 standard deviations. And then the mean plus or minus 3 standard deviations. So 99.7% of children will have a height between 91 and 109 centimeters. And now you might think, what was the point of calculating all of these values? If you're told to sketch this normal distribution, you need a scale along the horizontal axis to work with, and we're going to use these values. So you'll see from my sketch I've put 100 in the center, that's the mean, and I've got 3 of these markers on each side. Each one represents 1 standard deviation away from the mean. So you've got 100, so I have to add a standard deviation, so that's going to be 103, and again, and again, and you have to keep subtracting 1 standard deviation going in this direction, so 97, 94, and then 91. And we know that 99.7% of the distribution is in this interval. So values beyond 109 and values less than 91 we can safely ignore. There's a very small chance that a child will have a height greater than 109 or less than 91. So we have a workable scale. On the vertical scale we have the probability density function, and we're not interested in that. We're going to use our calculator's built-in statistical functions to calculate any probabilities. We don't need to know the equation of this curve to calculate any probability or area. So px less than 102, what does that actually mean? So it's saying, what's the probability that if we randomly select one child, the height of that child will be less than 102 centimeters? So that's 100, so 102 is roughly here. You don't need to be too accurate with this, it doesn't really matter too much. There's 102. Draw a vertical line so it goes straight up until you meet the graph, and then shade according to the arrow, shade to the left. We want heights less than 102, so I need the area of this region. So on the calculator menu, option 7, you can see the normal distribution, the statistical distribution. We want the normal cumulative distribution, that's option 2. Now it's got a lower value and an upper value. It's got a standard deviation and a mean. Now the standard deviation was 3, the mean is 100. But what about the lower and upper values? That's the lower and upper value for this shaded region. The upper value, the rightmost value for the shaded region, is 102. Normally you'd put these in order, but I'm doing it for a reason, starting with the easiest ones and working backwards to the most awkward one out of the lot, which is the lower one in this case. So what's the lower value? Because this area and this graph actually goes to minus infinity in this direction. We don't want to put something like that inside here. We just need something that's definitely not within the range of values that we've got on the scale here. So at the moment it's suggesting 0. I could stick with that, because if I did 0 it'd be way out towards the left, and that's a sensible value to use. So there's the probability. Just to demonstrate that lower value, let's say if I had 50, and then the probability is still the same, 0.7475. Let's say if I had chosen 90. Now it's a little bit different. So 90 wasn't a good choice. We want something that's outside, way outside, towards the left. So I want to stick with what I had before, which was 0. And there's my probability. So if the probability of this side is 0.748, if you want to work out the probability of this unshaded region here, remember all of this adds up to 1. So if you do 1 minus this value, and it's better to use the full value here than the rounded value, so 1 minus this will give you the probability on this side, which is the probability that a randomly chosen child has a height greater than 102 centimeters. Now on a sketch, you should always write probabilities on the top, so above this line, and below this line write down values of your random variable. So avoid doing things like this. That causes confusion between the numbers.